Hello guys and welcome. In this video I'm gonna explain to you about a linked list, how linked list works. I'm gonna explain to you step by step, and I will show you there are different operations you work on this linked list concept. Before we start, if you are new to this channel, please subscribe, it will help me a lot. CSPina, and if you enjoyed this content, please give me a like. Okay, so now I'm gonna try to explain to you using this image. Okay, so like you see in here, the first element is 8 is pointed to 9, 9 is pointing to 11, and 11 is pointing to 16. Okay, so there are 4 nodes. Okay, they are pointing to another node. Okay, so these data structures work okay by in chaining form. Okay, for example, if you look, the 8 element, what we call it in this case, it is a value. Okay, so 8 is the value, and it is this 8 with its node. Okay, it have a node pointing to the next. Okay, so this R is next. Okay, so it points to 9, next node is created, and 9 is a value of the second node, and it is pointing to the third node, and the same as follows. Okay, so the first value, what we call it in linked list, it is called head. Okay, head, and the last element is called 16, or what in your case they are different. The last node or in the linked list called tail. Okay, so that last node points to null value or empty. Okay, so there is no node, we say it to node. Okay, so in this case I will try to show you that there is only one node, it's pointing to null or empty node. There is no second node in this case. Okay, so this is the first node without a neighboring values. Okay, it have only one node, there is no second node. So the head and the tail, this is abbreviation. The H stands for head, T stands for tail. Okay, so the head and the tail are located on the same, okay, on the first node. Okay, so now I will explain to you using implementation of the code. Okay, so how to create this node and pointing or pushing. There are different operations we work on this linked list. Okay, so first let us create a class node. Okay, so class node. To create our first node, we need a constructor. Okay, so constructor, and we take a value. Okay, we take a value, then this dot value equals to value, and this dot next equals to null. Okay, so what I'm creating here is to create a node. There is at least one value, and it's pointing to the null or neighboring node. Okay, so I am trying to create this node blueprint. Okay, so now let me create my first linked list. So class, let me call it linked list. Okay, so this linked list have a constructor. Okay, so it takes value. Okay, so value. Now what I'm trying in here is I'm creating a new node. Okay, so new node, I am creating a new node, new, using object, it takes a value. Okay, so this constructor okay, creates a new node reference to that first node that have value and the next. Okay, so you have to remember this. Then to create our first new node, this that head. Okay, so this heading value, okay, this head node. Okay, so this head equals to new node. Okay, so this that tail equals to this that head. Okay, so this that length equals to 1. So what this code all about is, look at this image. Okay, so there is a value. Okay, a new node. Okay, we created a new node with it have a value of 12. Okay, and it's pointing to the null. Okay, so this constructor creates a new node. Okay, so this constructor creates a new node, and this head value, okay, the head value is with the new value, it's equal, okay, is with the new node, and the tail equals to with the head value. Okay, so the head value, if initially it was 12, the tail also will be 12. Okay, so the length initially it is 1. Okay, because when we create each node, its length is only 1. Okay, so this is all about creating our first linked list. Okay, so now I am trying to create, I will show you how to add another node or in linked list. Okay, so using a push operator. Okay, so now let me implement and explain to you. So when we add a node to this value, okay, for example, imagine this is 8 is a single node like this, imagine, then we want to add, or we want to push 9 node to the 8. Okay, so we have to create a new node. Okay, so how this possible, how to create this node, okay, how to push or how to join this node with my first node. Okay, so it takes a value. Okay, so let me create a new node. First we have to create a new node which equals to new node, reference to that first class, and it takes a value. Okay, so I created a new node with a new value, okay, for a pushing purpose. So what do you think, guys, we have to consider for pushing? Okay, so if not this dot 8, okay, which means if there is no head, okay, if there is no head, this dot head becomes new node, okay, and this dot tail becomes new node. Else, okay, else this dot tail, this is the else. In the else part we will add a new node. Okay, I will explain to you. First let me write the implementation. This dot tail that next equals to a new node. We created the next tail becomes a new node, and this dot tail become new node. Okay, so our length in this case, this dot length will increment by 1. When we add another node, it will become the length is 2. If you remember in the previous section, when we create a new only on one node, the length is, we say 1. Okay, so what if we add 2 nodes? They become 2, the length becomes 2. When we add 3 nodes, the length becomes 3. So that is why we do this incrementation of the length. Okay, so this and this else statement, this dot tail dot next equals to new node, means it creates a new node with a new value. Okay, so we have to remember this now, and also we have to return the linked list. Finally, the linked list. Okay, so this is how the implementation of linked list, how to create node with the linked list, and how to add or push a new value. Okay, so in the next video I will explain the different operations, but now let me show you the basics concept. Okay, in the push you have to understand. So if not this head means if there is no head value or the tail, there be the new node is all itself. Okay, so the new node is itself only. Okay, so there is no head value, the new node becomes the value. Okay, so in this case there is no new node, otherwise the new node becomes in the next value. Okay, so the length, like I told you before, it increments in each time. Okay, so this is how we implement linked list and create a new node and with a basic operation of push or adding a node. In the next tutorial I will show you different kinds of operation we work on linked list. So if you enjoyed this content, please give me a like and subscribe, and I'll see you in the next video. Hello guys and welcome. In this video I'm gonna explain to you the linked list pop operation. In the previous tutorial we look how to create a linked list, how to create node with a constructor, and we implement and we studied how we work with a push operation in linked list. In this video I'm gonna explain to you with graphics, drawing, and some code implementation of a pop operation in linked list. Before we start, if you are new to this channel, please subscribe, say Sabina, and if you enjoyed this content, please give me a like. Now let's start. So in a previous tutorial we implement the linked list with a push operation. So if you return this linked list, if you type like this, you can change it also to return this. Means this represents the linked list. Okay, so it returns your linked list. Okay, so remember to change this. Okay, so now we look a a pop operation in linked list. Okay, so how it works. So we look three scenarios. Okay, so for implementing a push operation in a pop operation in linked list, there are three scenarios. There are if you are looking at this image, the first, the head and the tail are pointing to null. Okay, so this means there is no value. Okay, so this means there is no value, means there is no node or there is no linked list, it is empty. So we cannot remove or pop one item from empty item, so this is undefined. Yeah, so the first scenario you have to recognize is if the head and the tail are pointing. If you are watching this, okay, the head is pointing to the null value, the tail is pointing to the null value. Okay, so in this scenario there is no value, which means it is empty or null. Okay, so in this case we cannot take out or pop out from empty, so this is undefined. This is the first scenario you have to understand in working with linked list in pop operations. Okay, so the second scenario you have to know or understand is that if you have more than two node or two values. Okay, so in this case we use two pointers. Okay, so these pointers are temp or pre. Okay, you can name whatever you want, but you have to use these two pointers. Why you use these pointers? It help you to pop the last item. Okay, so the last value of the node, it will help you. Okay, so how it works now, let me explain to you. So in this case the first node, the 7 node, is pointing to the second node or neighboring node, which is 8. Okay, so this 8 value is the second node. This second also node points to the third node, which is 9. Okay, so 9 is also pointing to the 10. Okay, the last or our tail node. If you remember in a previous tutorial, we call our last node or our last value, we call it a tail. Okay, so this tail is pointing to null value. Okay, so in this case we want to pop out this 10 node. Okay, so watch, this 10 node we want to remove. So how this pointer works, we initially set this temp and the pre variables. Okay, so these are variables we set to this dot head, because this first node is called head. Yeah, so we assigned to temp and pre to this head. Okay, so in the this is works in iteration, we use while loop. Okay, so when we work on while loop, this temp and pre node are iterating until temp dot next equals to null. Okay, so when that condition is true, it becomes the while loop deactivated. Okay, so now let me explain how the iteration works. Okay, so in the first case, the pre and the temp are equal to 7. In the next iteration, the temp dot next, okay, so the pre stays in the head node and the temp goes to 8. Okay, so in the next code they become equal, the temp go to 9, they become equal, they go to 9. Okay, so I will show you in the code also how they works. Okay, so after that, if the temp that next becomes null, we remove or we display that temp value is popped out. Okay, so this is how it works. The second scenario you have to understand in working linked list. Okay, so the last case you have to know is that when we have only single node or single value, if you watch this, the third image, the head and the tail are pointing in the same value 12. This dot here is 12 and it is pointing to a null value. Okay, so in this case how we pop out the logic, and I will explain to you with if you watch the code and if you watch this picture you will understand it. Okay, so in working with a pop operation with a linked list, you have to recognize these three scenario. If there is no value or node, we cannot pop this undefined. If there are more than 2 nodes in this image, okay, if more than 2 nodes, you have to know how to we use pointers, we iterate and we pop the last node. Okay, and the third scenario you have to know is that when we have a single node. Okay, so these are the 3 important things you have to know or understand in working with a pop operation. Okay, so now I'm implement the pop operation okay, using JavaScript. Okay, so now let's start. So first let me create my pop. Okay, my pop function or method. Okay, so the first scenario we implement is that, like I told you before, the head and the tail becomes null, it is undefined. Okay, so if this, if not this dot head, okay, if not this dot head means if there is no head value, I mean there is no value. Okay, so we have to return undefined. Okay, so this is for the first scenario. Okay, so the second scenario is that, like I explained you, we use 2 pointers and we remove the last node. Okay, we iterate that. So how this works, first let us create these 2 variables, temp and a pre. Okay, so temp, let temp equals to, okay, this dot head. Why this dot head? Because initially the 7 is the head. Okay, so we assign this temp equals to this dot head. Okay, so remember this. Now next we have to do is let pre equals to this dot head also, because initially we use these pointers at the starting or the head value. Okay, so this represents this picture. Okay, so remember this. So now, like I explained before, we have to iterate through for linked list. Okay, so while our temp dot next. Okay, so while our temp dot next iterates, okay, so the pre becomes temp equals to temp, like we assigned this while the temp dot next iterate, temp and pre becomes equal. Okay, this is true, they become equal. Okay, let me write it in better way. Okay, so pre equals to temp and temp equals to temp dot next. Okay, so and this means in the first iteration they become equal, then the temp moves to the next node, temp this. Okay, in the first they are equal, then in the second iteration the temp will go to the second node, and in the third iteration they become equal, and temp go to forward and backward, forward and backward. This is how it works in while loop. Okay, so after this iteration, then what will happen? Okay, so we now we are out of this while. Okay, we are now out of this iteration, and then this that tail becomes free. Okay, so after finishing this iteration, the tail becomes the pre. Okay, so we assigned to the pre node. Okay, pre pointer, and this that tail that next it becomes null. Okay, so in the when the while loop is finished, the tail that next it becomes null. Okay, so for example, if there is a value 11, and if it is removed and the tail is become null, like you see, but in this case is the 9. Okay, but if there is assume that if there is 11 node, and if we popped out, okay, so the 10 node becomes our tail. Okay, and the next is pointing to null. Okay, so you have to remember, and we have to we are popping, so which means we have to decrement the length. Okay, so this that length will decrement by 1. Okay, because we are popping a node. Okay, so we have to know this. So this is the second scenario of implementation. Okay, so I will explain to you the third scenario, which is the head and the tail pointing only on a single node. Okay, so this is the third. Okay, so in this case, if this case is called if this that head, yeah, so if this that head strictly equals to 0. Okay, so if this that head strictly equals to 0, this that head becomes null. You see this image? Yeah, so this that head becomes null, and also this that tail equals to null. Okay, so this is the third scenario if we have the same head and tail pointing on a node, and the next value is pointing on the null. We use this third scenario. Okay, so finally we have to return our temp or our popped out value. Okay, so we have to return the temp. Okay, so now we finished the implementation of the pop operation in linked list. Okay, so I hope you understand how this logic works a little bit. I'm not perfect, but I'm trying to explain how these three scenarios are important while you're working with a pop operation. Okay, so this is how we work. Okay, so the first is this if statement where it represents the first head and tail becomes null. This light and free pointer we iterate and we decrement. Okay, so this is the second scenario, and the third is that if we have a single node. Okay, if we have a single node. Okay, so if you practice and understand the logic, it is easy to implement. Okay, so practice and try to understand these problems. Okay, so this is all about linked list. It is a pop operation, how we implement, and we explained some concepts. Okay, so if you enjoy this content, please give me a like and subscribe, says Bina. And the next video I will show you some another operations we work on linked list. Thank you. Hello guys, and welcome. In this video I'm gonna explain to you the unshift operation in linked list. Okay, so what is this unshift operation means, I will explain to you step by step with a visualization of image and with implementation of the code. Before we start, if you are new to this channel, please subscribe, CS Bina. You will get more content like this, and if you enjoyed this content, please give me a like. Now let's start. what is unshift operation means. Okay, so unshift operation in linked list or creating a node and add to the first side of our linked list item. Okay, so in a previous tutorial, if you watch my tutorials on linked list operations, we implement the push operation to add elements at the end of our nodes. Okay, and also we implement the pop operation. Okay, so what is pop means removing a node, okay, from a last node. Okay, so we implemented these two operations on linked list. Okay, so if you didn't watch my these operation tutorials, you can get it in my channel CSBina. Okay, so in this video, what is I'm trying to do is that I am creating a new method or function. Okay, there are two scenarios for unshift operations. Okay, so like you see in here. Okay, so I create a new node which is a 4. Okay, so my point is that to assign or to add this node to the first side of our linked list. Okay, so before there is 11 node pointing to 23, 33 pointing to 44, and 44 to points to null. Okay, so we have 1, 2, 3, 4 lengths of linked list nodes. Okay, so now I want to create a new node. In this case it is 4, and to add it to our old version of our linked list, and it's become what the length increments by 1. Okay, so the head becomes 4. Okay, and this 4 is pointing to 11, 11 is pointing to 23, 23 point to 33, 33 points to 44, 44 points to null. Okay, so totally we have a length of 5 node or linked list we created successfully. Okay, so the first scenario is that for shortly for explanation. Okay, so the point is that to create a new node and assign it to the first side of our linked list. Okay, so in the first case the 11 is before adding. Okay, to in the first before adding the first 11 is our head value. Okay, and our tail value was 44. Okay, so this is my old version of a node. Okay, so my new version of a node is that when I add my 4 node to the first side of our linked list, the 4 become our new node. Okay, so this new node becomes the head. Okay, so you have to remember that when we unshift or add a new node, the tail will not affect it. Okay, so in this case it is 44. Okay, so 44 is the tail in the previous or old linked list, and in the first case our head value is 4. Okay, so the first scenario is that you have to understand this concept while working with unshift or adding a node. The second scenario, you have to understand that what if we don't have any collection of nodes. Okay, if it is empty value. Okay, for example, in this case the head and the tail are pointing to null. Okay, this is the second scenario. Okay, so you have to understand that this second scenario, the point is that we create a new node. In this case it is 4. Okay, so we want to add it in the first side of this empty. Okay, so after adding, it will become the head and the tail are pointing to this 4 or our new node. Okay, so this is the second scenario. Okay, if we have in case empty value. Okay, empty node, and it becomes like this. So this is the second scenario. You have to understand that we have a empty node and we assigned or unshift a new node to that old value or empty value. Okay, so these are the two scenarios you have to understand while working with a unshift operation in linked list. Okay, so now I will show you the cool part or implementation of this unshift operation in linked list. Okay, so now let's start. Okay, so in a previous tutorial we created this pop operation, okay, to remove. Now what we call it is the second operation, unshift. Okay, so unshift means adding a new node. Okay, with these two scenarios. Okay, so while working with unshift, it takes parameter of a value. Okay, it takes some value. Okay, so now the first case is that what we studied is that if we have a empty value or linked list. Okay, so if not, okay, if not this dot head. Okay, so if there is no head value, okay, so this dot head becomes what? The new node. Okay, so if there is no value, okay, if there is no head or tail value, the head becomes a new node. Okay, so you have to understand this. The head becomes new node in the, like you see the second image, the head become new node. Okay, also the tail become new node. Okay, because it is there is no impede. Yeah, so this dot tail becomes a new node. Okay, so this is the condition for the second scenario. Okay, so if there is no head, it become a node. Okay, it's pointing to null. If there is not head, also the tail also becomes a new node. Okay, like you see in this image. Okay, so the second scenario is that else. Okay, so you have to use else statement. If this is not the condition, okay, so this, which means they are a collection of nodes. Okay, so before adding these arguments, okay, we have to create a new node. Okay, so create const new node, it becomes a new node, and which takes value. Okay, which takes value. Okay, so now our value, then we created successfully a new node. Okay, so if there is not head, the head becomes new node and the tail becomes node. Otherwise, okay, otherwise next new, okay, new node, sorry, new node dot next. Okay, so new node dot next, it becomes what? This dot head. Okay, so what this code is all about, okay, when we add a new unshifting operation, okay, when we work on unshift operation, this new node dot next, which means that this point, okay, this arrow becomes the head. Okay, so and this dot head becomes our a new node. Okay, so the head becomes also the new node. Okay, so this is the second scenario you have to understand while working with a linked list operation. Okay, so what do you think that we left in implementation of this unshift operation? Okay, so if you remember that in the old version of after adding, it is the length is only 4. Yeah, so after we add this 4 node to the old version, it becomes 5. Okay, so the length is incremented by 1. Okay, so in each time, so this dot length increments by 1. Okay, increments by 1, then we have to return it. Okay, so we have to return this also. This means which means that that new created node, which is the unshift value. Okay, so this is the implementation of the unshift operation in linked list. Okay, so now let me show you how it works. Okay, now let me add a value. Okay, for example, okay, I created a new I created a new linked list, then I added or push 11, then also my linked list that's push 23. Okay, I am creating the old version of this node, or only the links of 4. Okay, my linked list that push 33, and my linked list that push 44. Okay, so now let me run it my code. Okay, let me check it how this push operation works, then I will show you what is the purpose of creating this unshift. Okay, so my PC is running my machine is low, that's why it takes time. Okay, so I am creating a push 11, 23, 33 and 44. Okay, so look, this linked list head. Okay, the node is that 4. Okay, 4, you see, then it is pointing to 11 and 23. In this case, let me delete it. Okay, and 11, 23, 33 and 44. Okay, let me create the old version of my linked list. Okay, let me save it and run it again. Okay, so what I'm creating here, that my old version of a node. Okay, so the first head, look this, the head value is that the value is 11. This is the 11, and the next node is that the value is 23. This is 23, yes, and the next node is that what is our tail node, okay, which is the tail node is 44. Yes, it is exactly 44. Then the next node, the next is pointing to null value. We created successfully our old version of a linked list. Now let me show you what is this unshift operation looks like. Okay, so my linked list dot unshift. Okay, let me add a 4. Okay, our new node, this unshift. Remember this, the old version is 4, the link is 4, 1 2 3 4. Okay, so there are 4 nodes in the old version of my linked list. Now I unshift or add a new node. Okay, so let me save it and run it, my code. Look, the link is 5. We created successfully. Okay, so the value is 4, 4 is pointing to 11, 11 we added to the first item. Look, this is the 4 new value. Okay, so previously it was a 11. Okay, previously the head value is 11. Now the head value is become 4. Okay, so we created successfully our unshift value. Okay, so 4 is pointing to 11, 11 is pointing to 23, and 23 pointing to 44. Okay, so this is how it works, unshift operation in JavaScript or in your favorite programming language. Okay, so the pointing is that to add a new node to the beginning of our linked list. Okay, so if you learn something new here, please subscribe to Spina YouTube channel, and if you enjoy this content, please give me like for more content like this, data structures and algorithms. And thank you for watching. I'll see you in the next video. Hello guys, and welcome. In this video I'm gonna explain to you the shift operation in linked list step by step. Okay, so with implementation and with an explanation of how this shift or operation works in linked list. Okay, so before we start, if you are new to this channel, please subscribe, say Spina, and if you enjoy this content, please give me a like. Okay, so now let's start. Okay, so now what we do is that, okay, so before we implement any operation, we have to consider the rules. Okay, so what are the rules you have to implement after understanding that rule or scenarios? Okay, so in the previous tutorial, okay, so we implemented the unshift. Okay, so we implemented the unshift operation, which means how to add a node in the beginning. Also we implemented the pop operation, remove of a node from the end, and we also implemented the push operation, which is adding elements in the end of the node. Okay, so these are the operation we looked in the previous tutorial. Okay, so now we are working with unshift or removing the first node from our linked list. Okay, so before implementing, you have to understand the scenarios. Okay, so what are these scenarios means, or the rules? Okay, so if you don't understand the rules, you cannot implement. Okay, so if you remember the code, it doesn't mean you will forget someday. Okay, so you have to understand it, the rule or the scenarios. What are the scenarios to remove a node from a linked list? Okay, so you have to ask these questions and remember the rule. Then after remembering the rules, you will implement it. Okay, so Now, shift means that removing a node from the first side of a node. Okay, so unshift means adding to the node. I added node to the first side of a linked list. Okay, so now we want to remove from our linked list to the first side of our collection of nodes. This is called a shift. Okay, so how this shift operation or method or function, whatever you call it, how this works is that you have to use these three scenarios. The first scenario is that if you have a node like this 6, 8, 11, 12, the head is 6, the tail is 20. Okay, so if you have a node like this, okay, so we want, or the plan is that to remove this, the first item, okay, this head value, the first item, okay, we want to remove it from our linked list. Okay, so this is, so after removing, this 6 becomes to null and the 8 becomes the new head value. Okay, so how this operation work is that we use a variable. Okay, so let's call it as a temp. Okay, so what this temp variable is do that, okay, so we assign to the first node. Okay, so after assigning that node, the temp will pointing to the second node, and we return it or remove the first item and return it that value. Okay, in this case it is a 6. Okay, so I will show you the implementation and how to shift or removing a node from old node. Okay, so after shifting, the links will decrement. Okay, so if you count it 6, 8, 11, 20, there are 4 nodes. Okay, so after working or applying this shift method or operation, okay, so our node becomes, the links is 3. Okay, 8, 11, 20, the links is 3, and we return it that shifted value, which is 6. Okay, so you have to understand this scenario also. Okay, so the second scenario, you have to understand that what if we don't have a collection of nodes? What if we have a single node only? Okay, so which means that if you face like this, head and tail are pointing on 3. Okay, so this is the only node you have to. Okay, so we want to unshift or remove it to the first side. Okay, see, so in this case it is only one node. Okay, so this is the second scenario you have to also understand. And the third rule or scenario you have to understand is that what if we have a empty nodes? Okay, so what if we don't have a node? Okay, so this is undefined because we cannot remove from empty value. Okay, from empty node we cannot remove, because this is also undefined. Okay, so this is these are the rules you have to understand while working with a shift operation or method in linked list. Okay, so remember these 3 rules. Okay, so now I implemented these rules and you will understand it more. Okay, so let me create a function or a method that is called a shift. Okay, so I created this shift. So okay, so now let me implement the third scenario, which is if we do not have a value, if we do not have a node. Okay, the head, the tail are pointing to null value. Okay, so this is undefined, like I explained you before. Okay, we cannot remove it from empty value. Okay, so in this case, if there is no head, okay, if there is no head, this dot head, if not this dot head, okay, then we have to return undefined. Okay, so we finished our third scenario, which is if there is no node we cannot remove from empty item. Okay, so this is not possible. Okay, so this is undefined. Now let me show you the second scenario. Let me create let temp equals to this dot head. Okay, so I'm creating a variable assigning to this dot head. Okay, so remember this. Then this dot head, okay, becomes this dot head dot next. Okay, so what is the second code is all about? this head, okay, we assigned the temp variable to this, the first head, and this head dot next means the arrow, okay, we assign it, okay, we assigned it, then the temp, okay, so the temp dot next is null, okay, like you see in here, it is pointing to null. We went to that node, okay, so we assigning to the temp dot next to null value, okay. So after this we have to decrement the links, okay, like I explained you in the before, the nodes are 4. After shifting the node or removing the first, the links will decrement by 1. In the first case, these 3 nodes, 6, 8, 11, 20, 4 node. After removing the first item, 8, 11, 20 only, there are 3 nodes, okay. So this dot length decrements by 1, okay. So you have to understanding how this works, okay. So this is the second scenario you have to understand while working with a linked list, okay. So we create a new variable, we assigning to the head, and the head dot next we assign the head with the head dot next, and the tape dot next will be null, okay, in this case, okay. So this is, then the links will decrement by 1, okay. So the third scenario is that if we have only single node or one node only, the head and the tail are pointing on that node. In this case it is 3, okay. In your case it may, the number may be vary, okay. So the head and the tail are pointing in this node, only single node, and it is pointing to null, okay. So now let me call it if this dot head, okay. So by the way, if you have a single node like this, in this case this 3, okay. So if you have a node like this, the length is what? It is 0, okay. So if the head, okay, if this dot head is strictly becomes 0, okay, the head if it is 0, we have to assign the tail to null, okay. So this dot tail becomes null, okay. So like you see in here, the tail and the head are pointing to null, okay. So why I'm not called the head to the null is that we created before the head will pointing, the head dot next, okay, pointing to null, okay. So the remaining is that the tail is pointing to null, okay. So this is also, you have to understand the code, how it works in working with Unshift operation, okay. So finally this temp dot next becomes null, okay. So the tail dot next becomes null, and we have to return that value, okay. So that remove the value in this case this 6, we call it the temp, okay. So we have to return this temp value, okay. So this is how shift operation implementation in JavaScript you can implement in your favorite programming language, but the main idea is that you have to understand these 3 scenarios while working with a shift operation or removing the first item from the node, okay. So this is all about removing a node from the first side of a linked list. If you learn something new here, please subscribe to Bina YouTube channel, and if you enjoy this content, please give me like for more content like this, data structures and algorithms. And thank you for watching. I see you in the next video. Hello guys, and welcome. In this video I'm gonna explain to you the set operation in linked list step by step. Before we start, if you are new to this channel, please subscribe Bina, and if you enjoy this content, please give me like. Now let's start. So what exactly means of this set operation in linked list, how it works, okay. So before understanding this set operation, first you have to watch the get operation in linked list, how it works, okay. So that is the base for this set operation tutorial. Okay, so first you have to understand that what is the gate operation on linked list and how it works. Okay, so I have a tutorial on that you can find in my playlist on data structures and algorithms, or in my channel you can get that specific tutorial on a gate operation in linked list and how it works. Okay, so because what I mentioned that gate operation is the base for this set operation, because we call that function for some scenarios. Okay, for writing clean code we use some calling of that function of gate. Okay, so first you have to implement and understand that gate operation. Okay, so now let me explain to you step by step the set operation, how it works, what is the scenario and rules you have to understand while working with a set operation. Okay, so now let's start. So what like you see in this image, okay, so there are five node values. Okay, so the first value is that 3, and the second value is 5, the third is 7, the fourth value is 9, the fifth value is 10. Okay, so the green, if you watch these green numbers, the 0 is the index of that specific value. In this case it is a3. Okay, so in the second node, the second node is 5, and it is index is 1, 2, 3, 4. Okay, so there are 4 index of nodes, and the links are almost it is 5. Okay, so this is a linked list. Okay, so what is the main idea of this set operation? Okay, so there are 2 scenarios before you working on this set operation. So the first scenario is that in the previous tutorial we discussed about this gate operation or method in a linked list. Okay, so the first scenario is that if our index is less than 0. Okay, so if our index is less than 0, or if our index is greater than or equals to our linked list length. Okay, so for example, in this case I write in red it is -1. Okay, so this is undefined because we return undefined because it is our index is less than 0. Okay, so it will not possible. Okay, so if our index is -1, it is undefined. Okay, so this is the scenario you have to understand before working or implementing the set operation in linked list. Okay, so the second one rule you have to know is that if our index is greater than or equal to our linked list length. Okay, so our linked list length is, we counted manually, it is 5. Okay, so but our index is greater than or equal to our length, this is also undefined. Okay, so this is the 2 rules you have to first understand while working with both gate and set operation. Okay, so this is the common scenario. It works for both situations, for gate and set operations. Okay, so the second one is that we worked in previous tutorial that we assigned a temp variable for the head node. This is in the first, as you know, we discussed in the previous tutorials, we called the first node is head and the last node is tail. Okay, so we assign to the first node head to the temp variable. Okay, so the temp equals to this dot head, means we assign a temp variable to our head node. Okay, that points to the head node. Okay, so this for loop will iterate from 0 up to less than our index. Okay, so in this case it will iterate the nodes and it will increment by 1, then it will change this temp variable by 1. Okay, it will increment, okay, and up to it will less than up to the index value. Okay, so and after that it will return our temp variable. Okay, so in the previous gate tutorial we returned that specific value of a node. Okay, so you have to understand that. Okay, so now why I'm explaining the gate operation is that before I implement this set operation, I call this function. Okay, so you have to understand why these codes are written here. Okay, so you have to understand this basic some ideas or scenarios in a gate operation. Okay, so after after set operation work. Okay, so the first is my old version of a linked list. As I told you before, there are two scenarios: if our index is less than 0 and greater than or equal to our index. Then the point is that we change a node value using that specific index. Okay, for example, if you watch, the first node is a pointing type is in the first head value, it is 3. Okay, in this case I want to change the 3 value at index 0. Okay, so remember that at index 0 I want to change the specific value of that node. In this case the value is 3. Okay, so after completing the set operation in linked list, it will update or set that to what we given to that specific index. Okay, so in this case I change it to that 0 index with a 4 value. Okay, so after set operation completion, the index 0 is 4, the remaining are the same because I changed it using that specific index. Okay, for example, I change it, you can change it to a specific index. For example, 2, at index 2 I want the 7 node to change it to something else, for example 12. Okay, so you can change like using the specific index value. Okay, so this is the basic idea you have to understand. Okay, so there are some codes we will not implement. Okay, we use this some calling of implementation for set operation. Okay, so now let me write some code of the set operation. Okay, so this is the first of get operation. Then after completing that get operation, I write a method called set, and I call this set method have a parameter of index and value. Okay, so it will have index and value. Okay, so now I use a pointer of temp. In a previous tutorial we also use the temp variable. Okay, so let temp variable equals to, okay, so let temp equals to this dot get. Okay, in this case we will not assign to the head value because that is to write a clean code we call another function or method. Okay, so in the previous tutorial we assigned the temp to the head. Okay, so in this case I will call that method. Okay, so this dot get, it will take index. Okay, it will take this temp variable index. Okay, so now if our temp is executed, okay, if temp, okay, temp dot value, it becomes the new value. Okay, it becomes temp dot value becomes the value, and if this code is run successfully, we return true. Okay, otherwise after if the statement will not work, we will return false statement. Okay, so this is the clean code we write on set operation. We will not write much more code compared to the get operation, because we will not assign this dot head. This for loop we call the method. Okay, so for writing a clean code purpose, I write this implementation of this set operation. Okay, so the main idea is that using the specific index we will assign the new value of that node. Okay, so in this example, like I explained before, in the old my node, the 3, okay, 3 is located at 0 index. Then after working operation of the set operation of this linked list, I changed that index 0 node to a 4 value. Okay, so this is the main idea of behind the linked list of a set operation. Okay, so this is all about a set operation in linked list. So if you learn something new, please subscribe to SAYS Bina for more content like this, and if you enjoyed this content, please give me a like, and I will see you in the next video. Hello guys and welcome. In this video I'm gonna explain to you the insert operation in linked list step by step. Before we start, if you are new to this channel, please subscribe to CS Bina, and if you enjoy this content, please give me a like. Now let's start. While working with a different operation in linked list, we discussed a lot of and we gain more knowledge while we implement and study the scenarios. Okay, so now I will explain to you the insert operation in linked list. First, before we implement and study the insert operation in linked list, first you have to fully understand the get operation in linked list. So what is get operation? I have tutorial on that. After watching that tutorial, you can watch this insert operation in linked list. Why it helps? Because while we'll implement the insert operation, we call that get method, okay, or that get function. Okay, so it is necessary to understand that rules in the concepts in get operation of linked list. Okay, so after watching that get operation in linked list and understand it, you can watch this finding of node in and insert in linked list, or this insert operation in linked list. Okay, so now let me explain to you this insert operation. Okay, so if you watch this the first three node, okay, so first node is pointing to the second node, the second node is pointing to the third node. Okay, so their index is, the first node is 0 index, and the second node is 1, and the third node is 3. Okay, so there are three indexes in the first linked list. Okay, so the main idea is to insert a node with different position of that linked list. Okay, it may be on the index of 0, or it may be at the end, or at the beginning, or at its specific in the middle between of the linked list. Okay, so the main idea is to insert a node with different kinds of positions in linked list form. Okay, so the first scenario you have to understand that is okay, so let me implement and explain to you step by step. Okay, so yeah, I write some first line of code, then I will explain to you what this operation or statement will do. Okay, so first let us create insert method. Okay, so after creating this insert method, it have two parameters. Okay, it takes two arguments. The first one is index, and the second one is text value. Okay, so these are the two parameters you have to know, or you have to add the index and the value in the insert operation. Okay, so the first thing is that if our index, okay, if our index of our new node, okay, so if our index is greater than 0, or if our index, okay, is greater than our linked list. Okay, so if our index is greater than 0, or our index is greater than our linked list size. Okay, so this is the statement. So this is undefined. Okay, we studied in the previous tutorial also on the get operation. This is undefined or false value. Okay, so because the index starts with the index 0, so, okay, so if it is, for example, it is -1, okay, this is undefined or false. Or if our index value is greater than our size of a linked list of lengths, it is also undefined. Okay, so we have to return it is false or undefined. Okay, you can say whatever you want. The second scenario you have to understand while working with a insert operation is if our index is strictly equals to our linked list length. Okay, so if our index is strictly equals to the our linked list size, this 3, for example, if this single node index is 3, okay, the index is 3, and if our old linked list is the total length is it may be 3, yeah, it is 3. So in this case we will add that new node to the end of that linked list. Okay, so which means if our index is equals to the length of our linked list, okay, our new node index, if it is equals to the size or length of our old linked list, we have to return this dot push the value. Okay, why push? We implement the push in the previous tutorials. We implement the push operation. Okay, so we create a new node and we add it to that value. Okay, so we call that function and added that specific value. Okay, so this new node will add to the end of that old linked list. Okay, so this is the second scenario you have to consider also while working with a insert operation. The third scenario or rule you have to know is that if our index is strictly equals to 0, okay, if our new node, the inserted node is index is 0, so we have to return Unshift. Okay, so why Unshift? Because to insert some value at the beginning, the indexes are also located on the starter value. Okay, so our index equals to 0, we have to return unshift dot value. We insert that node to the first side of a node. Okay, so these are the three if statements or scenarios you have to understand while working with an insert operation. So the second one is we create a const variable. Okay, and we say that we create a new node. Okay, we create a new node which is equals to new node and it takes value. Okay, I created a new node. So the third scenario is that if we are creating a new node and inserted to the specific position. Okay, for example, it may be we inserted it maybe in the position of index 3, index 2, index 1, index 0. Okay, so what if this condition will happen? Okay, so for creating this, we create a new node and we create a temp variable to iterate and set to that specific position of index. Okay, so const temp equals to this dot get. We call get method. Okay, so this get, we call this get method and we give it argument to the index -1 because after finding that index and it will increment by 1. Okay, so this temp variable will do that if you watch the get operation. Okay, so this temp will assign to this dot head and it will iterate from 0 to up to the less than to that index, which means -1. Okay, so this is the to create the temp variable and call that the get method. Okay, so I'm not go detail with the get method. What we'll do, I have a tutorial on that, you can watch them and you can fully understand what the get operation all about. Okay, so now after creating these two variables, let me create a new node dot next, which equals to, I will assign with the temp dot next. Okay, so I assigned this new node to the next and arrow. Okay, and the temp to the next arrow, it will increment by 1. Okay, so after that the temp dot next, okay, the temp dot next which becomes our new node created. Okay, so after this our length will increment by 1. Okay, and also we have to return after completing of this successfully code, we have to return true. Okay, so these are the three scenarios: the first scenario, the second rule, the third, and the fourth. Okay, so there are 4 rules you have to consider while working with a insert operation. Okay, so I call that this get method and to work with a clean code because it will assign the temp to the head value and it will iterate and find and replace that with the index of a specific position to the newly created node to that old version of a linked list. Okay, so this is all about of implementation of insert operation in linked list. Okay, so you can operate or work with create a object like this, let my linked list equals to linked list. You can give it and you can implement some operations and you can check how this method or functions are work. Okay, so this is all about the insert operation. If you learn something, please subscribe, says Bina, and if you enjoy this content, please give me like, and I will see you in the next video.